Good morning and good evening, everyone. Welcome to today's session about Informatica's journey to API security, where we're going to learn a little bit about API Sprawl, API discovery, and protection. My name is John Jeremiah. I'm with Traceable, and I'm really excited to be joined by Pathak Patel, who is the cloud security leader at Informatica. And our goal today in our session is to learn from Pathak his lessons and insights from his API security journey. So a few quick housekeeping things before we get started. First, we're going to take questions at the end, so please feel free to submit questions as we go. And second, chat with us. If you're having problems or issues or any technical difficulties, feel free to chat and let us know, and we'll work on sorting that out and solving it. So let's go ahead and get started. Pathak, would you like to introduce yourself and share a little bit about your background and how you ended up where you are?
Sure. Thank you, John. I'll start with my Informatica journey. I have been with Informatica for about past 6.5 years. Initially, I joined Informatica when they started their own cloud transformation journey, and I've been fortunate to build out Informatica security program, managing their software as a service cloud security. And before this, I've been individual contributor at startup, Netflix, Yahoo. So that's my background.
Fantastic. Well, let's get in and talk about your journey. I'm excited to learn from you and what you've experienced and learn about, really what happened and how you ended up there. And I don't know, I assume everyone knows about Informatica. It might be a good idea to share a little bit about, the role of what Informatica does. But can you share a little bit about Informatica and the challenges that you were facing and how were those challenges with API security impacting your business?
Sure. So I'll start with Informatica introduction. Informatica is enterprise data management company. We help our enterprise customers to manage their data and the data lifecycle. So when we talk about data, there is a lot of things that enterprises have to do around their data lakehouse or data warehouse, whatever term that they are using. But mainly, Informatica helps them with integration services, data master data management, data quality, and data governance. So it's a pretty loaded topic, data, right? Like, and when Informatica is in the middle of the data movement, this is where we are having a lot of challenges ensuring to our customers that Informatica is doing the right by their data and the privacy security of their sensitive customer data as well. So I'll give you some of the examples of products that we have. So we have integration services. So at Informatica, you can use our product to integrate your data sources, if their data sources are on your prem or on the cloud. Um, so one of the big challenges that arises with this is Informatica does not control or dictate what data a customer can manage using our environment. And when we say that, like, Informatica is a hub for processing all types of data out there. And on top of it, we are also storing a lot of sensitive metadata that allows us to connect back to customers' data sources. So underneath Informatica Cloud, we have many services and microservices that allows us to build a robust and scalable infrastructure for our customers. So being said that, uh, when you have a lot of services, these services are actually very tightly integrated with each other, and depending upon how the routing and how the uh, uh, data exchange is built out, they are exchanging lot of data between each other, and this data is certainly application data, operational data, and on top of it, the customer sensitive data as well. So if we look at evolution of API architecture, I want to mention here that Informatica started as an on-prem company. We have been like for past 25 years plus, we have been on-prem company. We had a very monolithic architecture, and from there we started moving towards cloud. And as you know, cloud brings us services and microservices like broken down architecture. So initially, when we started, it was very simple. We took our products, converted into a cloud native microservices, and allowed our customer to perform various operations on top of it. But as more and more services comes up, and Informatica's customers are requiring us to provide with integrated architecture, we had to evolve, and our application architecture is more complex now. So as you look on the right side of API diagram that we have put together, as of today, all of our microservices, they internally talk to each other. On top of it, we have API gateways, and these APIs gateways are also federated so that all the customers are coming to a central endpoint, and from there their requests are getting redirected based on various parameters to different microservices. And to do this, there is authentication, log management, routing, and various other services are offered. As we look deeper into this services, when a consumer or our customer, they submit a request, they typically go to front ends, and these front ends are internally looking up to authentication services, licensing services, subscription management, and then other application specific services which allow customer to perform a specific operation. So inside this application architecture, these different services are dependent upon each other to do their job. So one good example here is our authentication service. Any customer that logs in, it goes to authentication service and gets an authentication token. And this token is then relayed back to other services, for example, licensing to check what licenses customer has, or to go towards a integration application integration service where customer would take data from service 1 and submit it to service 2 to have it processed or have it integrated into a different data source. And while doing that, they are also asking a data quality service to perform data quality checks on this. So while I explain you, it may look simple, but authentication and licensing allows our integration services to determine what data can be exposed to a given request. And along with that, we our data quality checks, we a customer may not want to put data quality checks on the whole table. They may be interested in only performing the data quality checks on just two columns. So how do we ensure that all of this data that is being exchanged between the services, they are tracked, and we are aware of all of the data lineage, how they are going from one service to another service. So this is a quite complex problem that arises when enterprises are moving towards uh, microservices based architecture. On top of this, these days we are all moving towards Kubernetes, and in the Kubernetes, as we know, there is a many routing services, secret management, service discovery, and so on. So again, this because we are using all of these services in Kubernetes to ensure that Kubernetes is self healing and self operating from the perspective of deployment. But from the security point of view, it's a major challenge when all the services are living inside one environment and they have access to each other and each other's data, and they are transacting to each other in a most efficient manner. Let's go on to discussing what are the challenges that are out there for security team when we look back into this complex API architecture. So in the previous world, when we have monolithic or a single tier, three tier type of architecture, where you have your front end, your web server, and your database or backend server. It was quite simple to envision your security. You can cordon off all of your application, and let's call it a Fort Knox. This Fort Knox is pretty well locked down. But as we move on, now this Fort Knox has a lot of doors, and these doors can be accessed by internal and external consumers. And when a single door is responding to a request, this request is independently served by the each doorman. So one of the biggest challenges that comes out is the doorman simply is routing the traffic between the consumer and the producers. And these doormen, they don't have any authority on validating the data, or they even like modifying the data on what is going out to the consumer. So there might be a very clear issue where we or an application which is internal application, it may have a higher right to process sensitive data. But when the same application is responding to an external actor, it may want to reduce the data that it is exposing. But as of today, because doorman is just simply a router who is diverting traffic from one location to another location, they don't have a capability to understand and validate what's going on. So, from the security point of view, this is a major challenge, right? Like it is a major challenge from multiple angles. Let's start with your application security topic. So, in the application security engineer needs to understand from threat modeling perspective that how many API endpoints we have, what functions this API endpoints are offering, and when the consumer executes the function, what are the data being exposed. But on the other side, when you have hundreds of microservices, it is pretty hard to document and visualize what type of data is there, what are the functions, and what are the exposures to each other and to the external actors. On like if we next move on to routine maintenance and incident response, again, whenever there is a security incident or a security misconfiguration is happening, uh, we want to respond to those issues in a quite efficient manner. Like we want to reduce the time to respond. And for this, we need to be able to understand, quickly identify where a given API, a function, and a data is located, and how can we limit access to it? How can we protect that data source? So, being said that, we at Informatica, as we moved on to a complex architecture, it was becoming a challenge for our security team to track down all of this API endpoints, their functions, and their data exposure. We were relying on a very manual efforts where from design point of view we were looking to document how many applications, what are the endpoints, what are the functions, what is the application trying to do. But as we move on, our development teams are moving at a faster pace than the security team. And this also created a problem that even though we were documenting our API at the design and development time, it was inadequate by the time it reaches to the production environment. And also on top of it, because development teams are moving fast, they will be introducing new function, new data, new ways to interact, and this may not get to this this kind of behavior may not get well documented before it reaches to the production. So yeah, those are the few of the challenges that we have been experiencing around our API security and API management. So moving on, so I'll take our listeners through our journey of how Informatica was trying to was and is trying to solve our API security challenges. So, as I was describing in the previous slide, that we start with our requirement and design phase. So, in the requirement phase, we work with our development and our product managers to build out stories and map out the stories to understand that what are the application functions that are being written and what is the customer requirement, what is the consumer requirement. Once we have this documented, we go through a risk assessment process where we are trying to educate and document our development teams together with our development teams to understand, based on our requirements, what are the impact, what are the issues, security issues that customer may face, and what are the authentication, what are the logging mechanism that we need to build out to protect our customers from those type of issues. And as we move forward in the design phase, we are actually executing the threat modeling. So risk assessment, like threat modeling, is the next step from the risk assessment. So once we have done the risk assessment, we go through our various actors that would be interacting with our application, what type of data that they would be requesting and interacting with. So, for example, one simple example here is internal and external actor, both of them can be accessing the same application. So authentication application, this application can be accessed by uh, external customer directly to get the authentication token, but authentication token validation will also be performed by our internal application as well. So this is a good example of different type of actors and how they are interacting with our APIs. And this allows us to do the attack surface analysis, who is doing what. And once the developer completes their development, we move on to the deployment lifecycle. In the deployment lifecycle, we wrote internal in-house automation which will ultimately go through our Swagger files and build out a list of endpoints in the API specifications for each of the endpoints. And then in the last, we continuously monitor our application uh, through our dynamic scanning. So again, this dynamic scannings are implemented using our internal tools that are ultimately doing a DAST, dynamic application security testing, and through that we are documenting what are the endpoints, what are the function available there, and what data it is exposing. And this is actually a manual step where we try to correlate this information with our previous information where we have enumerated our Swagger files. And ultimately, um, on the continuous basis, we are also monitoring our web application logs to detect any unknown API endpoints that we haven't documented until this point. So, all of the application logs that are being transferred to our SIM, Security Information Event Management System, in there, we have a specific alerts and search terms built in that would allow us to monitor addition of new API endpoints. And once API endpoints are detected, we basically go ahead and feed that back into our dynamic scanning tool to ensure that we are able to document what are the functions and data that is exposed by a given endpoint. And at the end, protection is the last step. So again, protection is where we are trying to monitor any malicious activities and any of the issue that arises with our application scanning. And if there is any issues, then how fast we can respond. That totally was dependent upon our SIM solution right now. So this is where we started, and from there on we moved on to or we actually saw a need for moving on to a better system which is actually providing all of this information on a real time basis. So as you can imagine, right, when we have Swagger file enumeration, dynamic application scanning, and then monitoring on our SIM, these are all in a one way manual activity, because the output of this activities need to be correlated with each other, and need to be fed back in, so more and more data can be scanned, more and more API can be scanned, and information can be collected.
So, with it being manual, because I was about to ask about how this seems like lots of manual steps, did you have,
Correct.
I mean, it must have been expensive in that it took a lot of people time to do it.
Yes,
And,
John. That's yeah. Go ahead, finish it.
well, and it not only expensive, but it probably was also information that you didn't trust because you knew that it was manual. You knew that it was either out of date or people make mistakes. I mean, it's hard to be. Sometimes I have found with manual processes in the past where people always question the data. I don't know. Was that true for you as well?
Yes, absolutely. So one good example that I want to put forward, right? So I'll take example of dynamic scanning. Most of the DAST tools, dynamic application security tools that I have seen in my experience, they typically take multiple days to finish their scan. And once
Mm-hmm.
they finish their scan, it's a huge amount of data that you have to actually go through. Like let's say that the one of the first step it does is crawling all of your web application and your API endpoints. So when it completes that, the data that is coming out, it's a huge amount of data. You need to figure out what uh, how many of application endpoints are there, how do we document it, and then if our sim monitoring is again coming out with unknown API endpoints, then how do we insert that back into results of our dynamic scans? So the resource intensiveness, right? Like the one of the question that you are asking, there is a multiple impact here. The first impact is just the time itself.
Right.
When your dynamic scanning is taking a lot of time, and when your sim alerting system it alerts it, but it doesn't mean that as soon as it alerted we are going to be able to identify what endpoints functions and data is out there, right? We have to feed it back into a dynamic scan where a human has to go back, validate that information, and then put that information back into the scanning. So, if you look at Informatica's approach when we are implementing this, it was about 3 to 4 weeks when we would actually get a confidence that our release that recently went out, we have now a high fidelity confidence on the accuracy of our API catalog. So 3 to 4 weeks, right? And this 3 to 4 weeks, again, developer is ready with the new release of the application. So we are back to the square one. So in this scenario, a security engineering team, security incident response team, they never had a day when they can confidently say that yes, my API
Right.
catalog is complete and I have fully confident trust in it, so that if an incident happens, if something goes wrong, I'll be able to pinpoint. There was not a single day. We are always catching up.
Because you have development going at the speed of DevOps, so they're releasing as fast as they possibly can, and security is is stuck with their
It's
shoes
reactive.
tied together. Their shoes tied together, trying to keep up, and it must have been incredibly frustrating. So if you think about going forward and your pivot, and your transformation, the question would be: so what were the steps you took to break away and to move forward, and how did that, what was the kind of impact on your business?
Yeah, so that's a great segue here. So one of the first step we had to figure out, like how do we automate this, right? Like I was talking about a lot of manual steps. So obviously, first reaction is that all of the manual step, how do we automate them? What do we do to ensure that we have up to date information or near real-time information around our API catalog. And then the second part is like, as you do automation, you are trying to measure your automation and say that how much coverage do I have from the automation perspective, because automation is worthless if it is not covering 100% of the system. And then like there are other parts of the thing, right, like inspecting what the automation brings out and so on. So this is where a traceable shine for us. So in when we deployed traceable, the one of the first thing that we were able to quickly get out is the API catalog. And this was like a zero effort thing for us, because as soon as like, so in our environment, traceable is deployed alongside the federated gateway. So what this means is federated, like through federated gateway, traceable is able to see each and every request that is passing through our environment. And because of this, now traceable was able to provide us with all the API endpoints that are out there, and inside those API endpoints, what are the functions, what are the various functions that we have, and what data those functions are exposing to the consumers, whether the consumer is internal or external. And so this was a starting point. Then second point came was, how do we get a coverage, right? So um, again, as I explained, the federated gateway and integration with that federated gateway, this meant that we have the 100% coverage. On top of it, we also deployed our Kubernetes side of the agents. So this ensures that by any chance, if we have any misouts in the federated gateway, so think of the situation where some legacy microservices who have not integrated with federated gateway yet, and they are still serving traffic through their own dedicated API endpoint. So to cover this type of services, we also deployed agent inside our Kubernetes environment. This was actually ultimately tracking all the traffic that is going in and out of the Kubernetes environment. And that ultimately helped us get to the 100% coverage. On top of it, because this agent is ultimately a module in the middle of our traffic, it now has a visibility into all the data that is being exposed by a given API. And you can also catalog this data by the functions and different version of the APIs as well. So many time it happens, right, like as developers are developing the different version of their functionality, they change the data that is provided by each of the function, right? Sometimes they're reducing, sometimes they're increasing. So this is another quick win that we have, that we had, as I previously explained, like we were doing the dynamic scan. So this dynamic scanning, we were able to get rid of that dynamic scanning, and also the monitoring the unknown API endpoint through the SIM, because now traceable, by the virtue of it being in the middle, it is now seeing all the data that is it is transaction is going through. And in the last, the topic of protection. So you may recall that in the past slide, my explanation around protection side was very vague. We actually did not have much of the protection technology, except monitoring it through our SIM and then like being reactive to the issue that is coming out. But with the help of Traceable, we are now able to monitor all the threats, all the attacks that are being targeted towards our application, our APIs, and then also customize what responses we are providing, or how we are reacting to these attacks and threats. So this is a one stop solution that helped us from end to end, where we We are now able to automate our API catalog, get the 100% coverage. Whatever catalog that we now have a detailed information about application and data expose. Also classify what data it is exposing. Is it the sensitive data? It is application specific data. It is a secret data, like your secrets that flow between your application for operational purposes. So all of this is now documented in a single portal, and then using and armed with this information, we are now able to quickly respond to the threats and attacks.
It's amazing. So I would assume, and tell me if I'm right, but or not, but did that change the quality of life and the experience of the security team? Whereas in the past they were struggling to keep up. Is it different for them now?
Oh, absolutely. This is actually a good thing that for engineers, right? So when you ask security engineers to take data from SIEM, compare it with your dynamic scan, and inject new API endpoints, or validate these things manually, they are literally getting frustrated, right? Like we are asking these smart guys to basically do this manual work, like take this one point here, validate there, and all of that. They all of those guys hate it. Instead of that, now we have armed them with a tool which eliminates all of that manual work. And on top of it, as I said, like protection, right? So when security engineer, now he can do his real job, which is assessing the threat, understanding what is the impact, and based on the impact, like how do I respond. And also this response, all of this, they are able to do it in a very short period of time. Earlier, as I said, like we were just not able to catch up, right? So when you say you are not able to catch up, it builds a frustration and a feeling of emptiness, right? That I'm doing all this work, but nothing is really coming out. I can't really take any action out of it, right? I'm not confident. If I do something, if what if it goes wrong? So all of this thing, right? Like they are now out of that, and the work that they can do with the protection using Traceable, it's very accurate. They know what is happening. And on top of it, like one thing I'll take an example of here. So very recently, we were going through an attack, and in that, like it was a sporadic thing, right? Like it was not a continuous barrage of events that was coming in. The attacker will do some testing or recon for like an hour or two within our environment. He will go away. Next day, he again shows up and does something. But we know that he was trying to fish, right? Like trying to figure out that what are the weaker points and what to do with it. And on top of it, he was changing his IP address and tactics and all those as well. But the first thing first is Traceable. As soon as that guy comes up, we were able to identify them with some of the indication that this is the same guy that we saw yesterday, even though there may be a little difference in tactics. And then on the response side, right, like we wanted to make sure that this person, like whatever he is trying to execute, even though he's changing his tactic, we are able to respond quickly to those tactics. So our responses were uh, uh, how do I explain this is like it is in a single way that we did not have to customize responses for each and every time that the attacker shows up. Like we were like most of the time, what our engineers were doing was that they, as soon as they get alert, they log into the portal, they look at the HTTP traces that are available in the portal, and then validate that information using the previous information that is available for the same guy, and quickly determine that yes, this is the same guy, he's trying to just fish for it, very similar attack pattern. And they will monitor that behavior for the time period that he's around, and then as soon as he stops his behavior, we were able to declare that nothing has happened, all green. So these things we are able to do because we have one portal where we can see catalog, we can see the live traffic, and then we can see the responses that our application is sending back to the attacker. So we have like end-to-end guarantees that this is a, like, think of it as a window into what your web servers are doing, and this, through that window you are inspecting that yes, every thread, every process is doing the right thing and there is no exposure.
It's amazing. It's I love the story of how you had an attacker who was varying their tactics, changing their IP address, but your team was able to keep up with them, and you had, it was almost a level playing field. It sounds like you
Correct.
were
Yeah.
there. That's awesome. What did
And engineers are not frustrated here, right? They are enjoying the work actually because they are seeing that what they did is protecting enterprise application. So they are happy too now.
Patrick, that makes my day. I'd love to hear that. I'd love to hear how that had that impact on their lives and making them feel more fulfilled doing what they wanted to do and what they're being paid to do. How about developers? Did rolling out or adopting this sort of change impact people outside the teams outside of security? Was there an impact you saw there?
Yes, absolutely. This is it's quite interesting. Let me explain, or let me walk you through our experience, right? So on the day one, when we said that we want to introduce Traceable, we're gonna put it into the federated gateway. It's gonna sit in the middle of your application and do all this monitoring, right? Very natural reaction from developers that, what, you're trying to put something in between me and my customer. That's no good. Like, how do I guarantee that you will not mess up my environment, latency, etc. So this is where Traceable team was very helpful, right? Like, we they were able to help my team, like security team, and the developers to alleviate all of this concern. And as we build out our trust between these three parties, right, Traceable, security team, and the development team, we moved on and we were able to deploy this. But the whole aha movement, right, it came right after the deployment. um, because initially, when you look at the developers, they are very well focused on what their application does and how their application is responding, right? They got the request, their application did their work, and they put out the response back. They are happy with that. But now, with all of this API catalog, we the one of the big thing that came out for developers is that they were able to see the whole end-to-end behavior of the application in one single portal, right? And along with that, right, like, it was many times, like, there are many use cases, but let me just tell you about one of the use cases where it could result in Ebola, right? Broken object label access. So and this goes again, right? Uh, I'll be very vague, but this is just from the point of example. So think of, right, you have one application, and this application, right, like, developer says that yes, this is the functions that I expose, and here's the job that my application will do. But now, when other application inquires that the same information and presents it to the present issue consumer, the middle application may not know what are the access control associated within the downstream application. And in this scenario, like in the past, every development team was just worried about their own thing, right? That we did the right thing, and which was true, right? Like, that's how everybody should do. Like, I did this, and I want to make sure that my application is solid. But they never had an opportunity where they can see their application behavior from the lenses of the consumer or from the middle layer application. So with API catalog, now they are able to see this, right? Like, they know that I need to fix my data blob or my cookies or my some of my response parameter, because it may get exposed through the requesting application to the consumer in this way. So this is a great visibility that they got, and they were also able to identify some of this quite interesting things, right? Like where uh, un I don't want to call it a undocumented features or functions, but they basically are like, oh, I've been using this API function for all of my applications lifetime, but here's the another application function which is very similar, and it actually reduces the data that I get back, and I can actually do my job with that limited amount of data. I don't have to worry about filtering that data for my consumers. I just do that one call. It's a limited and exit data set that I need. So I had never thought about it. I'll just move from one API call to another API call. So this was another aha moment that my developers had. So think of this, right? That in the past, developers really did not have a conversation between each other on the behavior of their own application. Now we were able to make it public, and those developers were able to come onto the common ground, talk to each other, and then get a value out of their API calls.
That's fantastic. I mean, traditionally that would be where an architecture review, and processes would attempt to do that. But being
Mhm.
able to see how applications interact with each other, to see the end-to-end flow, I think is a huge enabler to help
Right.
developers do their jobs better. And it's in my background of having been a developer and an IT director, and then working in the DevOps space. I see the immense value that Traceable can provide of giving people that end-to-end view and visibility across the entire application. And
Yep.
in addition to the incredible value we provide for helping people secure and protect their APIs. So it's awesome to hear that story. So where do you go next? I
So
mean,
John, before
you
sorry, so sorry
yeah,
to interrupt you in the middle, but I just thought of very interesting thing when you mentioned architect, right? Architect and procedure. So
yeah.
I want to put this out here, which is as many time as my chief architect, our principal architect, right? As many time he logs into Traceable, he's like you can see his face. He literally feels like playing with a toy kind of behavior, right? He would go into like each of those application catalog, just click through everything, trying to understand and trying to like basically in his mind replay the architecture evaluation that he has done, the architecture design he has done, and all that, right? And be mindful that this is the principal guy, right? Like who is not in the day to day. He's at the top level, like the head of the committee and all that. So he knows everything, but this guy has not been into the day to day thing, so he doesn't know like actually details of this data and API calls and all that. So for him, this has actually become a toy. Every few days, every few weeks, actually, he pings me and he's like, "Hey, Pathy, can we walk through this application? Can you do a walkthrough for me?" And as soon as I show him around, he's like, "Thank you, Pathik, for doing this. You can log off. I'm just gonna play around." And yeah, so that's a fun activity for him.
I would love to be a fly on the wall and watch those conversations or hear them, because I can imagine from his perspective, with his seniority and his expertise about the applications and the systems and all of that, now is an opportunity for him to actually it's like turning the lights on. I mean, for in some ways he's flying blind. He's building an architecture, he's building a vision, it gets implemented, and other people implement the vision,
Yep,
and he doesn't get to see it. Now he sees it live.
correct.
He can
Exactly.
see it working, which is really cool.
Exactly.
Uh so where do you go next? What's your next step, and where do you see that impacting the business, and what's your roadmap, your vision, where you're going?
So I'll start with the developer part, right? Like we talked about the aha moment for developers, and we are actually doubling up on that, where um, we are now working with each of our development team to proactively work with them on publishing a data flow between API endpoints. So as I said, like developers had aha moment, and also our architect had aha moment, right? So we want to double down on that, where we feel that the whole development organization will benefit from this data flow, real time data flow, and enrich with actual data points, right? Like what is data being exposed, not just like definition of data, but examples and the type of data that is being exposed. So this actually allows our development team to quickly build out their future applications and understand that what are the impacts of their development, both from the internal side of it and external side of it. So this is the first part. The second item is, um, all of this reporting that we are building around the data flows, API endpoints, API calls, and data. We are also working with our developers closely, where we whatever we find as a security engineer, whatever we are finding, we are setting up this cadence meeting where we explain them that this is what we see. And for example, one good example would be an API call duplicating the data response, right? So um, so we are trying to meet with developers and trying to say that why do we have these two API calls which are exactly the same, and why are this used, right? And this basically sparks a conversation where they may say that we may be using for XYZ reasons, and security engineers would say that why don't we just merge it, or why don't we do a risk assessment validation of threat modeling points, and try to figure out that do we need this anymore or not. So that's the reporting, is a second topic that we are taking benefit from the traceable. And then now we are trying to implement traceable into the QA lifecycle. So what are the benefits here, right? Like when I say that QA lifecycle. So first of all of us have heard of like a shift left strategy, right? So from our point of view, we want to, when we bring traceable into QA side, it is actually building out the shift left strategy. So here, um, what happens in QA is as soon as the QA release is ready, it goes into the QA environment, and our QA engineers, they go through executing their regression, their hardness test cases. And during that, with the help of traceable, we will be able to identify the any of the data exposure, all of the vulnerabilities, or any of the misconfiguration that is happening before application goes into production. Because this is, think of this, right? Like traceable is like watching all of this in the QA environment, so it is building all the profile, and this profile is available during the QA lifecycle. And we know that our QA teams are going through those 100% test coverage. So we know that all of the API endpoints, everything is going through, all of those API calls have been executed, the data is exposed, and so on. So when we find issues, we can then have our QA team build out test cases so that when developers remediate that in their development cycle and push out bugs fixes, we can actually validate it quickly. In any future release, if a similar mistake is happening, then not only on that application, but any other application, we can catch the similar problems as well. So this is our shift lab strategy. It starts with deploying QA traceable in the QA lifecycle, finding out issue, creating tickets for those issue into development lifecycle. Developer fixes that, and QA writes a test case to validate them. So this is a whole complete life cycle, put it into our QA environment. So when application is ready for production, it has a minimum amount of bug and security configuration. And we have a high confidence that we are putting out a secure application for our customers to be able to use.
That's fantastic. That's a fantastic story. As you were describing your shift left, I started to think about the potential you could even have pen testers or red team, go into the QA environment and interact with an application later in the life cycle as a pre-production process too.
It's a good point. Actually, for us, like at Informatica, the pen testing is actually part of QA.
Oh,
So
so
we
there you go.
are, yeah. So that covers all of those QA plus pen testing use cases. So in reality, we are envisioning a world where our QA or pen tester, they wouldn't know that Traceable is watching them,
Right.
because this is like basically has to be transparent to them. If we are if we if those guys know that there is a somebody watching them, like for example pen testers, they might be careful, or they might be trying to avoid the system or game the system or things like that. So we want to be transparent as much as possible, so that exactly the same behavior can be caught, whatever it is, right? It's a QA automated test case, or it's a pen test. We can catch and we can monitor that behavior in its natural environment, and then report issues based on that.
Fantastic. Very cool. So we've covered a lot of amazing ground. I love a lot of the details of your story. And I really do appreciate all of the insight you've shared and what you've experienced. If you were to sit down with your peers, with other security directors or CISOs, other security leaders, the question I often have would be, what was your lessons learned? What would you tell someone else who's in a similar role as yours, what they need to do and how they need to think about solving API security? And then, what are your next steps? Where do how do you see, closing thoughts on what you see as lessons learned, I guess?
Yeah. So one thing that I want to start with is API security is a part data challenge as well. So you want your tool that you're selecting, you are implementing, has to be able to scale to your web application scale, right? So in terms of this, both from like catalog management, the documentation of what data, what API calls, and all of this, it needs to be near real time processing so that you have accurate information. On the other side, why I say that data is this is a data problem is that as this tool is interacting directly with your web application, it also generates a lot of data, security event data, on what is happening with your application. So uh, not only on the catalog and documentation side, it needs to be able to scale, but also on the output side, right? You need to be able to make sure, or you need to ensure that your tool is scaling up to the millions of requests that your applications are getting, and then putting out meaningful and actionable items for security engineers to be so that they can act upon in a timely manner. um, so that's the first thing I want to put together. Second is around developers. So API security, like throughout my whole experience, right? Like as I explained, right, we had some manual efforts, then we brought in the Traceable, and we worked on the Traceable with our development team. But in this whole life cycle, developers were the key. We had a pretty good relationship with developers from the day one. Yes, agreed that they were questioning our implementation style, how we are deploying, and all of that. But if you keep them around, if you help them understand what benefit it is coming out of this tool, and how this tool can be actually enabler for their day-to-day job, then they are more than happy to do it. um, so um, so my advice for my peers is, whenever you are trying to implement an API security program, first sit from the developer side, look from their lens, and trying to understand how they will be benefiting from this. Some of the advantages, right? I already talked about the data flows and sharing the information, sharing our vulnerability, our threat actors data. All of this data we share with our developers. We did it afterwards, but if you start helping them understand that this is what the benefits you will get after the deployment of API management tool, then they will be much better partner in the whole journey.
Fantastic. Thank you so much. You know, it's funny. It's a paradigm shift of security helping developers to be
Mm,
faster and more efficient. In my history of being a developer and working with developers, rarely have I seen that opportunity for security to contribute to going faster. But this is
yep,
a case where it's very true.
correct. And
So
we, like as a security team, right? Everybody, I think my peer will agree to here as well that we have a talent shortage, and even if we did not have shortage, there is never going to be enough strength on security team so that they meet the speed and agility of development. Right, the development team are like typically in the big companies, it's thousands of developer, but your security engineers are just tens of security engineers, so they will never be able to match it. To have a successful security program or any successful security journey, you should have your developer as your partner and have them do stuff on behalf of you, so you can do your real job, which is threat management, risk assessment, and responding to the critical issues in a near real time.
so true. So completely true. So, Pathik, now we're at a point where we've got some time for questions from the audience, and we'll take a look and see what questions we have and answer those questions.